Okay, so hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company, provide technological solutions across the world. Now see, in our last 12 classes we have been discussing that exactly what is PyTorch, how it is working, right? And when we were practicing this PyTorch and its programming, we were using Jupyter notebook, and we were using Google Colab facility, right? So for practice purpose, Jupyter notebook is perfect, right, for practice purposes. But when we talk about the project, right, when we talk about the project, what happens? We have to create a directory, right, when we working on Python, right? Because Python support PyTorch, right? So PyTorch, all PyTorch libraries will be supported by Python. So for practice purpose, we run the code on the the Jupyter notebook, right? So that is fine for our practice purpose. But when we have to present a project, or when we have to create a project and present it in front of the client, in that case you can't show that working code on Jupyter, because the client is the user, right? And he is not having that much knowledge of technology, that how to use that. He need a very simple user interface, and then he need a very simple that either he should be able to see something on the screen, or he just click the button, or he just select the file, right? The user know only few things. One is clicking the button, second is selection of files, third is a drop down list box. That's it. So for presentation purpose, or for a project, if we see project point of view, we have to prepare this project into the Python. For example, take any example like image recognition. In my CNN related video, convolutional neural network related video, I have shown you that how these numbers are predicted and recognized. So that program can be written completely as per the Python standards. We can write down all the programs, but for that what we need to do, we have to create some architecture of folders, and we have to make some folders, we have to create some files. Because if I show you like this, for example, look at this. This thing cannot we can't run like this, right? Okay, so what happened? Just give me a second. Need to just see here that exactly how it is working. So first of all, we need to design of architecture of folders and files, right? And inside that folders and files, what we need to do, we need to put the code inside the files, right? By file. After that, what we need to do, then we need to execute those files in the Python way, not in the Jupyter way, right? We have to execute that code in the way the Python understands. So first of all, what we need to do, what is going modular, exactly what does it means? And today's session is not that much big, because I am just showing you the way of implementing the PyTorch code into the Python folders or Python files, right? So what is going modular? Going modular involves turning turning notebook code. Look at this. Going modular involves turning notebook code from a Jupyter notebook or Google Colab notebook into a series of different Python scripts that offer similar functionality. That's it. For this, what you need to do, data setup.py file. It's Python file. Every .py extension means it's a Python file. A file to prepare and download data if needed, right? Then engine.py file. A file contains various training functions. Whatever the training functions that we write in our Jupyter notebook, that will be written in modelbuilder.py. Model builder means model.py, a file to create a PyTorch model. And if you remember, we have been creating the model function also. So that model function will be written inside this model.py file. Third is train.py file. If you remember the training function also, we have been written the training function in that Jupyter notebook. So that complete function will be written in this train.py file. And utils.py, a file dedicated to helpful utility functions. Whatever the functions we will write, we will use, whatever the library we are going to use, everything will be written in this utils.py file. For example, look at this. What we are going to build, right? Now see here, if you see what we are going to build, so prepares data. If let me increase this, just give me 1 second. I am going to increase this and just 1 minute. Yes, okay. Now see this. First of all, I am going to increase this here. Let's look at this. Now it is clear. What is written here? Going modular, data.setup, that means prepares the data. Functions to train test, engine.py. Builds a PyTorch model, that is model.builder. Trains a Python model, that is train.py. Utils, utility functions, and then trained models will be written in this .pth file, right? Then data. Now see, everything will be written in, for example, as you all know, machine learning requires the historical data also, then only it will be able to work. So data in standard image classification format. There must be one folder in which several photos of one particular category should be saved. For example, if we have a folder of pizza, so maximum photos of pizza, all type of pizza images should be there, then only it will the machine learning will be working in a better way, right? So that is why it is written here. Look at this image 01.jpg, right? So it is very mandatory that suppose if we are making a code in which the machine should learn, so we need the historical and the database code also, right? For this we need to prepare a folder also, and inside that folder several images of different varieties and different types should be stored in that. Say test. Now you can see here train and test, two different folders. Inside two different folders there must be several images, then only it will work perfectly. Okay, so that is why it is very mandatory. And same thing is written here. Look at this. If you see this image, same image is here only, right? So this is how it works. Now let me show you the code also. Look at this. Now if you see the code, let me start from the top level. First of all, creating a folder for storing Python script. Now see here, import os. Now os.mkdir. First of all, you have to import it in from DOS prompt, right? Import DOS, import os. then os.mkdir going modular folder. Now see, if you see the image here, going modular, this is the outermost folder, right? So that is what it is showing, outermost folder going modular exist underscore okay equal to true. Okay, then get the data. Then inside that you have to create one more file, that is, look at this here, this. First of all, you have to bring all the important libraries, and then data equal to path data pizza stick sushi. We have given some predefined folder paths, right? After this, what we will do here, if image path is directly, if it is exist, then it will prompt it already exists, right? And if the path is does not exist, in that case also it will prompt, right? If the path is not existing, then with open, this is completely, we have already learned this in our last few sessions. Request dot, now this is the link where you will get all the list of all the images, right? Look at this, pizza stick sushi, so all the images will be pulled here. Then with zip file, now look at this, that with zip file, if you see as zip file zip ref, right? Then if you go, yes, now if you go here doing this, you will see unzipping pizza, okay, setup. After that we will train the data, right? We will train the module from here, from PyTorch data loader, correct? After that, if you see somewhere, we have to look at this. Now data setup.py, write file data setup.py, because our today's target is not to learn the programming, right? We have to understand exactly how the code is arranged inside the folder mechanism or the architecture, right? Folder architecture. So now if you see here, write file going modular, again it will write file, and if it will put all this below file data inside that file, and writing going modular, then data setup.py. Inside this data setup, everything is written here, right? After that, making a model. Now again, as usual in our PyTorch process, what will happen, we have to make a model here, and then this model is created, that's fine. Import torch, we have to use CUDA if torch CUDA is available, otherwise either CPU or GPU, right? Then here is one more function, here you have we received here information. Then if you go here, checking out the model by doing dummy forward pass. So here we have written, let me show you that particular information, model builder. Look at this model builder, right? Inside this model builder, so write file model builder, and now inside this model builder, this complete information is written, correct? After that, if you go one more, where I will show you, just a second. Okay, so model builder, inside this complete code will be written. Okay, now look at this, writing going modular model builder.py file. Again this py file will be created. After that, import torch, then going modular, import torch model builder, right? Device equal to CUDA if torch CUDA dot is available. This is as usual, we have learned already all these things, right? So now we will go ahead and get a batch of image and labels from the data loader, right? So it will pull down all the images from the data loader, right? And now this was up to just we have to write down here like this, model builder train.py, right? So inside this train.py, we have to write down each and everything. Now creating train step and test step functions and train to combine them. So this is how we are writing the train step. As usual, we have seen this is the process of training, the batch, and then you will see at the end test also, then test also, test step, right? So we have given the test step and torch.influence mode. Okay, after that we see here from typing from import dictionary, right? When we talk about the Python, right? So inside this Python, dictionary is called and list is called, because maximum task is done with the help of dictionary and list. From tqdm.auto import tqdm, and then definition, that is a function train. Here function train is written here, right? And now function test. First of all, write file going modular dot engine. Now see here, this engine.py, right? So this is how engine, this complete function will be written inside that engine.py. After that, what was the next step? Test step, right? First was train test. This is the train step. After that, if you go down, test step is here. This is the test step, and then train model, right? Look at this. And after that, you will see here, after running the epochs, writing going modular engine.py, everything will be written inside the engine.py. Clear? Then creating a function to save the model, because everything, if the load comes on a model, so we have to check creating a function to save the model. So we will first save the model, right, inside the database. After that, if you see here, create model, save path, create model, save path, assert model, model name dot end with dot pth. This is all standard coding. After that, if you see, write file going modular utils.py. So what is this utils.py? Look at this, utils.py. So whatever written here, if you see, whatever written here, that will work for this utils.py, right? Now from pathlib import path, import torch. Now in this Python, what happens, you have to use the torch and the path also, right? Save model. Now the another function is save model. So right, so model equal to torch n dot model, and then target dictionary, and then the model's name, both are same, right? After that, target dir path equal to target dir, and target dir path mkdir. It will create one more directory, make one directory, right? Assert. Now see here, assert model dot underscore name. Okay, so model dot ends with dot pt dot pth. It will create one library also, right? So this you have to write down, write going modular slash utils.py. If I show you this utils.py, exactly what is this, is the utils.py, right? Then you will see here, train, evaluate and save the model. As usual, training is mandatory, training and saving, right? So it will train the, first of all it will write down each and everything with the help of command, write command, right? Then train, evaluate and save the model. Okay, so train, evaluate and save the model. So first of all, what we need to do, train, evaluate and save the model. First of all, we will take some epochs like repetition, right? So inside this repetition we will run and execute some epochs. So what will be the output is this. But the thing is that this is not understandable by the client, right? So for this we have to provide some landmark also. We have to provide some additional information, right? Then train, evaluate and save the model. Train, evaluate and save the model. So what will happen here? Train, first of all we will train the model, right? And after that we will evaluate whether the it will checked with the current data, right? After that we will hand over it. So that is why we will use a write file going modular.train.py. Now if you go here, writing going modular, if I go you just a second, 1 second, right? Train and now look at this here. Here you have written going modular train.py. I have already shown you the train.py. Look at this, right? So it will work like this. Torch vision dot transforms and import v2, right? Here everything is as usual, right? You have to just copy and paste, and if you don't need to copy and paste also, writing going modular / train.py. So there are so many facilities that we can use this. So now if you see here engine.py, so whatever the working we needs to be done, that is for engine.py, right? And then util.save save model. So we will save the model. So writing logical writing going modular train.py, right? So train.py ne, so due to the train.py it will train. Now if you see here Python train.py, how it looks like, it will looks like, right? Similarly if you go to my home, let me go here. If you go to my first slide, right, the complete game revolves around this, right? What we are working towards, right? For example, the data setup, engine.py, all these py files, the reason is that the .py extension belongs to Python. So that is why we need to create one architecture like this. Now what my suggestion to the audience is that you watch this video twice, thrice, right? And then try to understand, try to make an image that exactly how the work is going on, right? Because in this IT field you need to hit and try continuously. Okay, so after doing all these things, if you go here, look at this, look at this. If you go going modular, look at this, the data and pizza test pizza, look at this. Okay, again once again I am going to show you going modular here, and then you will go going modular folder, then you will see here the data is a steak sushi train. Let's take here, look at this. Okay, so this is what I wanted to show you today, right? Now this was all about how to arrange, right? For example, if I'm giving you one daily life example in when we used to learn any other language, right? Let's suppose in LKG or the first standard, the student listen and see all the words, English words, right? But at that time he does not know that exactly where these words are used. But as soon as he grow up, he comes to know exactly how to arrange the data. Same thing is here, data Python, right? Because every integration is a different integration. So that is why that is again a different integration. And in our next session I will teach you something else. And my suggestion is to all the audience is that go through this video once, twice, thrice, right? Okay, so now today we are concluding here only, and in our next session we will come with some other example, right? Some other topic, some other subject. So guys, for today we will stop our session here only. And one more thing, my suggestion is to all the audience is that watch this video twice, thrice, and if you have any doubt in that, you can easily ping me on the comment box, right? Or you can put your query whatever in the comment box. I will resolve that. Okay, thank you guys, thanks for watching the attending the webinar and the bootcamp. And if you are new to this channel, then please subscribe my channel.